the elimination method for solving our systems of equations. And as I said before, you're going to have the majority of those 10 problems you have for homework to do. You are going to be setting your own system of equations. And most likely, the same thing will happen in those, that you will need to rename both equations. Now, there are going to be options. Not all of us need to rename using the same multiplier. So we all get to pick how we're going to rename them, but what do we need to create? What's the most important thing in your renaming? What has to be the end result?
Opposite for
Opposite.
the variable.
Opposite x terms or opposite y terms. Does it matter which one?
Yeah.
No, you get to pick. Okay, so there's all kinds of options. So anybody can, let's name one option here. Notice what I did. I'm kind of like giving us a spot to think out loud. Okay? So what could we do? If you multiply that first one by what? So you're going to make a decision. Do I want to create opposite x's or opposite y's? And then if I do, what would I multiply by? So Blaine, you got an idea? Okay, I'm just going to write it down and then we'll decide which one we're going to use here. But what do you want to do?
For the negative 5x, you could multiply by negative 1.
Okay, and our goal in multiplying it by -1 would be to get, what are you trying to eliminate, the x's or the y's? The x's, so then that would give us a positive 5x, okay, right? Okay, so then what would we have to do to the second one? By a -1? Is that what you said? Okay, so we're going to multiply the second one by a -1 also, and then we would get a -2x. Are those opposites? No, so we could do that, but it wouldn't get us anywhere, would it? No. So, Cole, do you have another idea?
Get the top equation times 2.
Okay, you want to multiply the top one by 2 because you, which variable are you going to be trying to eliminate, by the way? X's or Y's? The X's. So if I do that, that would create a -10x. And then what would I multiply the second one by?
Negative 5.
-5, okay.
Positive 5.
Positive 5. You want it to be a positive 5, okay. And then if I took positive 5 times 2x, I'd get a positive 10x. Would that create the opposites like we need? Okay. Notice I didn't even worry about the y's right now because whatever one I'm zeroing in on, whichever one I'm saying I would like to eliminate the x's, here's what I would have to do to make that happen. So there's a possibility. Isaiah?
You could multiply for the y's. You could do. You could take the top one by 6.
Take this, the top equation times 6. Okay, I'm just going to put it, because it's the y's you told me you're trying to eliminate right now.
Oh, actually, never mind. Not 6. We can do 3.
You
Actually.
want to do 3. Okay, now we'll change it to 3. Okay, so if we multiply that one by 3, that would create a what?
6y.
6y. Okay, and then what would we, 6y, not 64. What would we have to do to the second one then?
Multiply it by negative 2.
By -2, we'd have to multiply that one because then that would create a
Negative 6.
-6y. Would those be opposites? Yeah, so that would work too. So there's another option. And notice Isaiah was starting with something bigger than he needed to. Could he still have done that? Could he have multiplied by 6? Yeah, but then he would have had to multiply by a bigger number in the other one also, right? So you have lots of options. Let's go with the one that I filled in the blanks over here, okay? Not that I don't like yours, Isaiah. We're just going to use the one I already have there, okay? Okay, let's go to work doing that then. Let's take our positive 2 is going to be multiplied, the first equation. Both sides of it have to be multiplied by that 2. And then, I'm just going to write it down for right now so I remember that I also have to do this other one. I'm going to take the other one times 5. So I'm going to take 5 times 2x plus 3y and 5 times 10. So they each have their own multiplier. And I have to make sure I do it to both sides. So go ahead and rename those two equations because you know how. You know how to do the multiplying. And then see if you need to, after you're done, see if you need to challenge me and say, I think maybe Mrs. Agrada needs to change your mind. So you like your names, you like my names? We all have the same? Now, if somebody uses a different multiplier, are they gonna get the same names? No. Does that matter? No. What matters?
That they're
Opposite.
opposite.
That either the x's are opposites or the y's are opposite, and in the end, will we get different solutions then? We start with different names for our equations. Does that mean we'll get different solutions? We better not. It's only one place these lines are intersecting, right? Regardless of what names we work with. Okay, so I'm feeling pretty good about mine because my x's look like they're opposite, so I'm going to get them lined up one above the other, and so that I can get ready to add them together. So get them lined up vertically, like an addition problem. And then we can see, once you have them lined up like this, and you start adding, if you don't get to cancel one of them out, you better stop and say, hey, wait a minute, something's wrong here. I can't have both the x's and the y's when I'm done adding. I have one, and one of them has to cancel out, one of them has to eliminate. So I get that we can cancel the x's and that we have 19y equals 114 when we add them together. Okay, and what do we do next?
Divide both sides
Divide both sides by 19. And I see that that ends in a 4, so I'm thinking, you know what, 9 times 6 ends in a 4. Maybe it's 6 times. Is 19 times 6 114? It is. Well, what is 20 times 6? 120, and I went up one too many 6 times. What's 120 take away 6?
104.
See, we can do this without our calculators. 114 actually. Y equals 6. So we get a 6 for our y value. And now what do we have to do? What's next?
Doing the beginning of the equation.
We gotta go solve for x. How many actually choices of equations do we have to put it in?
2, 4.
We actually have 4. One of them and its new name. The other one and its new name. So it doesn't really matter. We could use any of them. Look at this one, you like 10, 15, and 50. You could use that one if you wanted to. Which one would probably be looks like maybe the friendliest to use?
Bottom one.
Bottom one, the 2x plus 3y.
There's no negatives in that one.
Yeah, so let's use 2x plus 3y equals what? What was that one equal to? 10? Okay, so now we're going to substitute our y value in. We're solving for our x. So we're not doing a check problem here, we're doing a solving problem where we're substituting in what we found y to be, what we think it is anyway, and now we're going to solve the equation that we have for x. So go ahead and solve and you see if we get the same solution.
And
I get x equals -4. Anybody else get that? Okay, good. So what we're going to say our solution is? Isaiah?
We're going to say our solution is ordered paired. -4, 6.
Okay. Do you have a question too, Isaiah?
No, I was just going to say that I did a completely different, I went a different route and I did 10x plus 15y equals 50, and I did get.
And you still got x equals -1. Good. So we can use different equations, but we should still all end up with the same result. We can all use different names for the equations, but we still better end up with the same result in the end.
Do we do check problems on the homework today?
Actually, I'm not going to have you do check problems today because the majority of them are word problems, so I'll just let you just solve and cross your fingers that you have the right one. If it's an odd numbered one, you can use the back of the book and double check it if you wanted to. Doesn't mean you can't do check problems, but I'm not going to make you. Okay? Anybody else? Questions or concerns before we move on? Okay, let's go try another one then. you like?
Multiply 5y by 4.
Okay, so you want to multiply the first equation by 4 because you said you're trying to get the y's to eliminate, so we to get a 20y if we did that, right? Okay. Then what would we have to multiply the second one by, Martin? 5. Okay, so if we multiply the second equation by 5, we're going to take 5 times 4y,
It would also
and we're
be
going to get
Negative.
20y.
Negative.
But they're not opposites, are they? So we'd have to make it a negative 5. Could we make the 4 negative instead of the 5? Would it matter which one was negative? No, it doesn't matter, does it? Okay. So what's another option that we could probably, try on this one? Riley, what do you think?
For x's, you could take 3 times 2x.
Okay, and so that's going to get us 6x, and
then
then
you could take 3x times negative 2.
if we took the bottom equation times negative 2, we get negative 6x, right? So that would be an option. But notice I'm only worrying about doing it just to the x's at the moment, just saying this is how I can eliminate the x's. Are they the only thing that are going to get multiplied though? No. Okay, so that's another option. Okay, what's another? Are there some more options? Or in other words, how about Riley? Could we make the 3 negative and the 2 positive? Would that matter? Wouldn't matter, would it? Okay, let's work with the one that I took from Morgan just because it's over there in my spaces. Okay, and we're going to take the first one, she says, and multiply it by 4 to rename it. And then we're going to multiply the second one by negative 5 to rename it. And remember what I said, if you're finding that you're getting these wrong, what ends up happening sometimes is we forget to multiply all the pieces. And then that ends up causing trouble. Okay, get the new names for those. And before I go to work anybody, I'm going to let you confirm that I have good names for my equations, my good new names for my equations. Anybody like 8x plus 20y equals 104? Yeah?
I
Let's
don't
do
know.
that one. Well, 4 times 25 is 100, and 4 times 1 is 400 plus 4. You got to learn strategies of how to multiply without having to line it up in your head and do the, good old-fashioned multiplying. 26 is the same as 25 and plus 1. Take each of them times 4 and then add them together. Okay, how about my other equation? Negative 15x plus 20y equals negative 125. That's a negative 1. Negative 20y, it's kind of hiding at the bottom of the y tail there. So all of them had to change to negatives, right? Okay, then let's get those lined up. Ready to add together. 8x plus 20y equals 104 plus the one that has all negatives in it. We're going to add those together. When we get that addition problem set up like that, if we look at it and we can't cancel either the x's or the y's, stop. Don't even go any further. Get back up there and start trying a different name. Or find out where you might have multiplied wrong or something. Because our y's eliminate this time, don't they? Okay, what's 8 plus negative 15? Negative 7. So that's negative 7x. And what's 104 take away 125? Or plus negative 125?
Negative 21.
Negative 21. Go ahead and finish solving that one for x. I got x equals 3.
Yeah.
Okay, we're going to beat each other's check. Okay, now you pick. Which equation? Go on what I do. You pick your own equation. Go and use it to solve for y, and let's see if we all end up with the same result like we should. I got y equals 4.
I got that too.
Anybody use the same equation I did?
Nope.
I don't think anybody would be crazy enough to use that one. It's not really a very, efficient choice, but you know what, I just thought I'd be different. Because my point is, should we all get the same y value, regardless of which equation we use with x equals 3, right? So our solution is ordered pair,
3, 4.
3, 4. We're not done until we write that. When it's not a word problem, where we know what x and y are representing, we need to then say, okay, well, here's that ordered pair, that point on the graph where they intersect. Okay? Questions on that one at all? Okay, then let's go to our books. You need to open your books to what page does it say?
346.
346, okay. So for those of you who have SQ3R, this problem will look familiar. Those of you who have not going to. And for those of you who did SQ3R and have done it already, we're going to do it again and we're going to see how well you did, okay? So would you read that problem to yourself? And after you're done reading it, would you decide what x and y are going to represent in this problem? And then remember, we have to be specific. And our specificity has to really refer to like what, not to make something up. Okay, somebody give me an idea what we could let x and y represent. Carly?
X is the cost of lilies.
Cost of lilies. So is that an unknown?
What?
Is that unknown? Because remember, x is the unknown. Is that an unknown, or do we know how much lilies
Oh,
cost?
how many?
How many? Yeah, it's the number of lilies. We already know how much each one costs, so we're gonna figure out how many. And then y would be the what, Isaiah?
Number of tulips.
Number of tulips then. Okay, and by the way, it does not matter which one gets to be lilies and which one gets to be tulips. What matters is that when you're setting up your equation, then you're going to set up your equation properly, okay? So, now that we've decided that x is going to represent the number of lilies and y is going to represent the number of tulips, we got to set up our equations accordingly. So, anyone want to offer up one of the equations that we could use to solve this? Christian, what do you think could be one of them?
1.25 x plus 0.9 t. I mean y.
So now you happen to use that. Equals something?
14.85.
1480.85, okay? This tells me, when I look at this, this is what this tells me. That every lily costs $1.25, plus the cost of the tulips, which every tulip costs 90 cents, and altogether apparently this had a total cost of $14.85. Is that right? Is that what it tells us? Okay, then that's a good equation. What would the other equation be that would help us solve this problem? X plus y equals 13, she says. Okay, here's what that tells me. The number of flowers that are lilies, add to that the number of flowers that are tulips. Altogether, there are 13 flowers. Is that what it says? Okay. Well, then we're ready now to solve our system of equations. Let me make a suggestion to you, okay? I didn't do this the other day. I wanted you to see how much more work it is when you're working with decimals. But I want us to rename that first one, just multiplying by whatever it would take to get rid of the decimals. That's where we're going to start. Let's rename that first one, multiplying by something that would get rid of the decimals. Now remember, Christian said 0.9. He didn't even want the 0 to be here. He just wanted it to be 0.09y. What could I do that would eliminate those decimals? Isaiah? Multiply by 10? Would 10 eliminate all of the decimals?
Oh, you
Probably not. We'd have to multiply by
100.
100. Yeah. And the reason I took that 0 away is because sometimes there is, some of them are out to 10, some of them are out to hundreds, and others might be out to thousands. You want to get rid of the decimals, so you're going to have to take it times enough to get rid of them all. So you know what? We're going to rename this first one multiplying by 100. So let's come down here and do this. Let's take that first one and rename it so what's that one's new name? Multiplying by 100 is same as doing what? Moving the
Decimal over 2 places.
decimal 2 places to the
Right.
right. So how many x's do we have? 125 of them. How many y's do we have? 90. And this becomes 1,485. Okay, now looking at that equation, let's take that other one, x plus y, and let's decide what, remember we have to rename our other one also. Let's decide what could we multiply times x plus y that would give us an opposite x or an opposite y, considering that now this is how many x's we have and that's how many y's we have. Michaela, what do you suggest? Negative 90. Okay, because if we multiplied by a negative 90, we should get the opposite y term, right? So let's take both sides of this one times negative 90, and we're going to have negative 90x plus negative 90y, and now we have to take negative 90 times 13. It's going to be a negative, I know that much. Negative times a positive. $1,170 is what it should be. Okay. Now we have our two equations renamed. And notice by renaming that first one, so we got rid of the decimals, it made it really easy what to decide to multiply the second one by. If we had not renamed that first one, we'd have been trying to multiply by decimals to rename, and it would not have been fun. So we're going to take our 125x plus 90y equals 1,485, and add to it our negative 90x plus our negative 90y plus our negative 1,170. And all is well because our y's are going to cancel. So go ahead and solve for x. You get 9 for everything, but you agree with me? Okay, take away one more person, that's good. Okay, we should all get 9, that is what should happen. Well, it's going to be pretty easy to get y. What do we have to do? Which equation would be the most efficient to use? X plus y equals 13, yeah. We have 9 that are x. Subtract 9 from both sides. What is y? 4. Okay, does our answer make sense? That it could be 9 and 4? Okay, because 9 plus 4 is 13. 13 flowers. Feeling pretty good about that. Okay? But instead of this time writing our answer as an ordered pair, because we know what that x and that y represent. We said it at the beginning of our problem. What sentence answer are we going to write? What were we trying to find? Ricky?
I don't know, I just randomly raised my hand.
Okay, Carly?
There are 9 lilies and there are 4 tulips.
Okay, was it somebody buying these? Was there a person involved? Sally, and she was buying, or was
Sally
she?
bought
Yeah, there we go. I like that. Sally bought.
9 lilies and 4 tulips.
Okay, she bought 9, and we don't abbreviate anything else. You do get to use the numeral for the number instead of the word. Sally bought 9 lilies, and we don't use an abbreviation for that either. And 4 tulips. Now, if we had let X and Y, let's say we let X represent the number of tulips and Y represent the number of lilies, would that have changed this answer? Would she have bought 9 tulips and 4 lilies? No. It's gotta be 9 lilies and 4 tulips. What would have happened though? If we'd have switched X and Y's roles around, then when we were solving, we would have gotten X equals 4 and Y equals 9. And we would have looked up there and said, oh, X, that 4 is what? Tulips in my situation, and 9 is lilies. You gotta look and see what did you classify them as. And then we all have the same final answer. Always. Okay? So any questions about word problems and the expectation for those, because several of them in your homework are word problems.